Okay, so for this first video we have a trig review. We're going to do a little functions of trigonometry. We have sine, cosine, and tangent. And up to the right side you see there is sine, which is the opposite over the hypotenuse, cosine, which is the adjacent over the hypotenuse, tangent, which is the opposite over the adjacent. And over here we have our right triangle. Remember, this little sign right here stands for a right triangle, or you could see a little square in the corner. It makes a squared off motion for a 90-degree angle. And remember, the hypotenuse is always going to be opposite of your right angle. And then here is our angle, and your adjacent leg is going to be the angle that runs alongside, the leg that runs alongside of that angle, and your opposite leg is going to be the leg that is opposite of that angle. So if you're solving for angle theta, remember you got to get rid of sine, cosine, or tangent, because see, therewith sine and the angle equals the opposite of the hypotenuse. So in order to get rid of sine, if you had to solve for the angle and you knew the two sides, you would just divide by sine, which makes it the inverse sine times the opposite of the hypotenuse equals the angle, or the inverse cosine if you're going for the adjacent over the hypotenuse, or the inverse tangent, which is the opposite of the adjacent. Now hopefully this is just a little review and you remember this from your previous maths, but if not, I will help you out in class and we'll get you straight and ready for the semester. The Pythagorean theorem, remember, that's how you solve for the sides of a right triangle. If you have two of the three sides, all you have to do is a squared plus b squared equals c squared, and that will give you that third leg of whichever one you're solving for, that third leg of the right triangle. Okay, let's move on to a practice problem to use some of these trig functions. Alright. We have a triangle here, and you'll see this on the second slide of the PowerPoint presentation, in case you had problems with it in class, or if you're looking ahead, get a little hand with it. We have a triangle here where we have sides. This side is 4, this side is x, and the angle's 41. We're wanting to solve for the x. So in order to do that, I need to decide which trig function do I need. Well, my angle is right here, so this side is the opposite of that angle. This side is adjacent to that angle, so opposite and adjacent. I look over here and I say, this is opposite hypotenuse, opposite and adjacent. This is what I want to use. I want to use the tangent function. So I will use tangent 41 degrees equals, and that equals the opposite over the adjacent. So now I'll say opposite is 4, the adjacent was x, and now I'm going to solve for x. I need to get x by itself. So the way to do this is I need to get x over here, because you cannot divide by the numerator. Remember that. Please never, ever, ever do that in this class. Remember, in math, you can never divide by 4 to get rid of it and leave x by itself, because that would leave 1 over x. That's not leaving x. So we got to get rid of x first and put it over here, and then get it by itself on this side. And this is how we do that. We just multiply both sides by the denominator, which is x. So that will leave us with x times the tangent 41. Make that a little more legible. X tangent 41 equals 4. And now I still have to get x by itself. So how do I do that? I'm going to divide both sides by tangent 41. So that'll leave me with x equals 4 divided by tangent 41 degrees. And if I get my calculator out, and I just type it right in just like that. Let's put in 4 divided by, a tangent function is right here, tangent 41, close my parentheses. Sometimes you don't have to close parentheses, depends on which type of calculator you use. Some are more sensitive than others. I don't think you have to on this type of calculator, the TI-30X2S, but I did it anyway, and my answer is 4.60. So in this class, you do need to know the significance of the significance of significant figures. We'll know in labs significant figures will be more important, but here I don't just want you putting 4 because our significant figures in here was a 4 here. I don't just want you just putting 4 or 4.6 rounded up would be 5. Go ahead and put it at least to 1 decimal place. So we're going to put x equals 4.6. And that would be our answer for that one. And I'll let you know as we go on. I'll let you know how many significant figures to put your answers to in each type of section. But for right now, 1 decimal place is good enough. I just realized something in that demonstration I just did. I didn't have the right angle marked. So this was our right angle. I apologize for that. So this was our right angle. That's what made this side the hypotenuse and this side the adjacent. I'm sorry, and this side the opposite and this side the adjacent. Sorry about that. Clear that up real quick. Now let's try another example. Alright, and here we have our next example, example B. We have a triangle here. Here's our right angle. This is the angle theta that we're dealing with, 57 degrees. Here's a side that's 10.8, and here's a side that's x. So we're solving for these, this one right here, and we only have this one and the angle. So we look over here and we say, okay, what do we have here? Which trig function am I going to use? Well, this is our angle, so this side is opposite of the angle. This side is at the adjacent of the hypotenuse. You know it's the hypotenuse because the right angle is here, so it has to be the opposite of the right angle. It's also the longest side, but sometimes that's not obvious, readily obvious to see that which side is longer. Sometimes they can be very close in measurement. So here we go with right angle here. This is the hypotenuse. This is the adjacent. We're not worried about that, this triangle. We're just trying to solve for the hypotenuse. So if we have the opposite in the hypotenuse, which trig function are we going to use? If you look over here, the opposite and the hypotenuse are going to be the sine function. So we're going to put sine of the angle, sine 57 equals, and that is the opposite over the hypotenuse, so 10.8 over the hypotenuse, which is x. And then we're going to solve for x like we did before. We'll have x times sine 57 degrees equals 10.8. And then now we'll divide by sine 57 on the other side, on both sides actually. And now x is isolated. We brought x over, then we divided sine 57, and now x is isolated. So 10.8, let's find out what that is. 10.8 divided by sine 57 equals 12.8777. Let's just round it to 1 decimal place. That's 7. We'll round that 8 up to a 9, so 12.9. And that will be our hypotenuse for this triangle, 12.9. Alright, the next practice example on the PowerPoint presentation is 2A, and it leaves us with a triangle that has an angle of some measurement. We don't know what it is. It's represented by the Greek symbol theta. So we have theta, but we need to find the measurement of that angle. We are given sides 6 and 9. We don't have this side. Obviously this is the opposite side. So we're given the adjacent and the hypotenuse. Remember, I know this is not adjacent because it's opposite of the right angle. That makes it the hypotenuse. So this is the adjacent, this is the hypotenuse, and the adjacent is 6, the hypotenuse is 9. What trig function am I going to use if I have the adjacent and the hypotenuse? I'm going to use cosine. So I'll have cosine of theta equals, and it's the adjacent over the hypotenuse. So the adjacent is 6, the hypotenuse is 9. Now, I need to get theta by itself, the angle theta by itself. We're solving for the angle this time, so I need to get it by itself. So I'll take the trig function and use the inverse of that trig function to get rid of it. So I'll have theta is equal to the inverse of cosine 6 over 9. Adjacent over hypotenuse. And all I got to do is plug that into my calculator. And to use the inverse, all you have to do is on the TI-30X2S, hit the second feature, the second button, and hit your cosine. That'll give you the inverse. And then I just type in 6 divided by 9, and that gives me 48.189. I'm going to round that to 48.2 and make that 48.2 degrees is the angle theta. Alright, in our last example for this slide, we have 2B. We have this triangle. And notice where it's BAC and others, there's been like CBA. There is no definite order of sides. I mean, they do go where it'll be, there's 3 sides to a triangle. Sometimes it'll be A here, B here, C here. It could be A, B, C. They could be rearranged in any fashion, so don't worry about anything being out of order. It's a triangle. There's only 3 sides. One's going to be A, one's going to be B, one's going to be C. Okay, for this one, here's our trig functions written up here again. We have an angle theta we're looking for, and we have the opposite side is 11.9, the opposite of that angle, and then we have a line connecting to that angle. Now, is this the adjacent leg, or is it the hypotenuse? It's very important you know, because that'll tell you what trig function to use. It is the adjacent leg because, remember, the hypotenuse is always opposite of that right angle. So here's our right angle, there's the hypotenuse. So we're dealing with the adjacent leg and the opposite leg. Adjacent and opposite gives us tangent. So just go through there, see which one you need. So we know we're looking for a tangent function of that angle, with tangent is nothing more than opposite over adjacent, so we're going with the opposite, 11.9, over the adjacent, which is 10, and we need to solve for that angle. Remember, the only way to get rid of a function is to use the inverse of that function. So we're going to go with the angle theta is equal to our inverse tangent, and again, it's the opposite over the adjacent, so it's 11.9 over 10. And now, go into your calculator, and okay, so we get into our calculator, and we're going to type in the inverse tangent, which, remember, inverse is second function, tangent, and 11.9 divided by 10, and that's 49.95. Now, you have to look. That 5, it's going to round that 9 up. So instead of 49.9, we're going to have 50.0 for our angle. So theta equals 50.0 degrees.